Hello, IB Physics. Ms. Getz here. Today I'm going to help you set up our second lab for the year, and this lab is focusing on rubber binders, or rubber bands, or whatever you want to call them. You have two in your IB kit, and we're actually going to look at both of them. Half of our class will look at the blue one, and half of our class will look at the beige one. And as you guys said in our discussion post last week, or 2 weeks, whatever, there's lots of things you can investigate about a rubber binder. I could fling them across the room. I could fling them at things. I could stretch them out and see how they stretch. There's just tons of things that we can investigate. But what we're going to focus on is their stretching and how their stretching works. And ultimately, I want you to create a mathematical model that will allow you to predict how far your rubber binder will stretch if you hang not one, not two, not three, but 4 sets of 50 pennies. So this is 200 pennies from your rubber binder. How far will it stretch? Will it even be able to take that much mass? That's what I really want us to be thinking about. And so ultimately, to do this, we're going to have a research question of how does the mass hanging on a rubber band affect its stretch? Take a moment and think about this research question and think, which of these two variables, because there's two variables, I'll underline them, there's mass and stretch, two variables, which one would be the dependent variable, that thing that we think is depending on the other thing, and which is the independent variable, the thing that we are changing? Take a moment. Awesome. So I hope that you recognize that our amount of stretch is our dependent variable that we're thinking probably is affected by the mass. And so that changing the mass will cause the stretch to change. Take a moment and think about what your prediction would be, and take this moment also to write down this research question in your lab notebook and get your lab notebook started, because you are going to ultimately be turning in pictures of your lab notebook. So start doing that right now. Awesome. So then, thinking about what our control variables are, again, I said half the class will look at the blue rubber binder, half the class will look at the beige one. So one control variable that you might think of is that you want to keep the rubber binder the same. You don't want to switch between experiments. Your last name is going to decide which rubber binder you have. Look at the directions. And so you'll have your one rubber binder. I'm going to use the beige one. And the way that we're going to need to set up this lab, so you're going to need a variety of materials from your lab kit to be able to do this. You'll need some paper clips. I have 2 small and 1 large. You will need a rubber binder according to your last name. You'll need your cup that has some holes punched in it. That's going to be really helpful. You might find the little clip helpful. You might find your string, which I already tied up here, sorry. Your string from your pendulum lab helpful. You will need both sets of pennies. And I caution you, when you open up the set of pennies that doesn't say do not open, the one that you can open, don't fling it against a surface, because then the pennies go everywhere. Don't ask me why I know that. And then the other thing that you're going to need that's really very important is your ruler paper. So you'll need this ruler paper. I want you to use this ruler paper, not the ruler strip. Ruler paper. It'll make our lives easier, and also it'll all be calibrated the same then. So once you have these supplies, you're going to need to find some way to hang your rubber binder from something in your house. It needs to be something fairly sturdy. It needs to be something where you don't have a lot of safety concerns. I'm here at the top of my stairs, but I'm being very careful. I'm sitting on the floor, and I don't have anything about to tip off the stairs. So be very careful in whatever location you find. One thing you might find is helpful. Oh no, I lost my paper clips. Don't lose your paper clips. Oh, okay. Is hanging a string, tying a string. So again, you can cut up your pendulum string if you need to. Now we've used it as pendulum, and use that to tie onto something. If you have something that has a good lip or a little drawer pull or something, again, you can be creative and figure this out. I'm not going to show you 8,000 different places you could hang it. You can figure it out, problem solve. I have a little lip here that's quite secure, so it's got a bump. So what I'm going to do is actually fasten this around it, and this is actually fairly secure. So I'm not hanging a ton of weight off it, but you do want it to be fairly secure. You also want to make sure you're not going to damage anything in your home. So then what I'm going to do is I'm going to take my little paper clip and just open it up a little bit. Oh, a little bit open. I'm going to decide which side I'm hanging this from. Doesn't matter too much, but you just want to make sure that you keep it consistent. So here I have this paper clip hanging. Then I'm going to rubber band onto it. Excellent. And then you're going to need to make your own mass container. And by mass container, I mean container for your pennies. And the way you're going to do that is take your little Dixie cup that has holes in it and the big paper clip and unfold the big paper clip so that you can thread it through the holes of the Dixie cup. So through the holes of the Dixie cup. This is not that hard, I promise. I just make it look harder on camera. So then I have it through the holes, and I'm actually going to tip it, bend these out a little bit more, tip it so that the hanger part is upwards. So here's a little spot where I can hang stuff from. And then I'm going to bend these just with my fingers to be securely pointing up, curling around, I don't know, up to you. It does not need to be fancy. Mine actually looks pretty ridiculous. Maybe yours will look cooler than mine. But it just needs to be able to suspend. And I have tested your little holes there will be fine. So then you're like, Ms. Gatz, I can't hang it from the paper. That's what the second paper clip is for. Third paper clip. So my third paper clip, again, is the little paper clip. I'm going to bend it slightly and thread it through so that now I have paper clip, cup, and attach that to my rubber binder. Okay, so now we have a setup that is almost complete. I have my rubber binder hanging here very securely from a binder clip and a paper clip, rubber binder, paper clip, cup where I can put some pennies. Excellent. So this is partially set up. And the other thing that we need is to be able to measure the stretch of the rubber binder. Because our testable question, our research question again, is how does the mass hung on a rubber binder? Again, I've got my pennies as my masses. With this combination of pennies, I can have anywhere from 1 to 100 pennies in this cup. Again, leave this one rolled up. Do not open. These ones are free. So I can hang them easily here. But the other part of the research question is how does it affect the stretch of the rubber binder? So what is stretch exactly? It's definitely a measurement with distance somehow. But take a moment and try to think about, well, what would it mean to measure the stretch of something? Awesome. So the stretch is going to be looking at not the total length of the rubber binder, but how far it has increased its length, or rather its change in length. So I'm going to call this right here kind of its like base or starting length. And there's a couple different ways you could do this. If you wanted to, and you had a lot of time to like do a lot of engineering and taping of stuff, you could arrange your paper so that the zero of my ruler, and again, I want to look for the 0 in centimeters, which is on this side, my bad. The 0 right there, I could have that be right at the bottom of the, it doesn't look like, your perspective and my perspective are different, dun dun dun. I could have that right at the bottom of the, this is terrible filming. Yeah, you're welcome. I could have it, I'll just point with my finger, right here is where I could have the 0 lined up, so that any amount that it then changes is what the ruler measures. But that's a huge pain and involves a lot of like moving stuff around and being like, oh, I don't know, is it there yet? I don't know, is it there yet? I don't know. So what I am going to do instead is I'm going to take some of the tape from my baggie, and you'll have to pick that off. I should have picked that off earlier. So I'm taking some of the tape, and if you're sticking this to like a wall or something, I recommend sticking it to yourself a little bit first so it gets kind of fuzzy. so it doesn't remove any of the paint on any surfaces that you're sticking it to. So your parent or guardian, no one gets cross at you for doing science. So what I'm going to do is I'm going to finagle a way to have it hanging right here. And again, you want to make sure that the ruler is perpendicular with the ground. It's going straight up and down. And I'm just going to take a little moment to kind of mess around and make that happen. Whew. Okay. So that took a little bit of finagling. And again, you can figure out an arrangement that's going to work best for you. If you had some sort of like large box or something that you could put right behind the hanging cup, or maybe it was like next to a wall or something, that would also be very convenient. But I've arranged mine so that it's mostly, it seems pretty perpendicular to the floor. I have a little bit of tape on two sides, and now I can see, taking my trusty physics pencil, right where the bottom of the rubber binder, so here's the bottom of the rubber binder, I can see where that starts on my ruler. And so I'm going to actually mark off where the starting point is on my ruler. I'm drawing with my pencil. This is from my perspective from where I'm sitting, so it might not look exactly the same for your perspective where you are sitting. Okay, so I have an experimental setup here. I've got some pennies. I've got my rubber binder with a little mass holder below it. Whee! And take a moment and think about, should I go like 1 penny by 1 penny? What's your thinking on that? Okay, so you probably noticed that there's like a lot of ways you could do this. I could go 1 penny at a time, I could say. Okay, here's some pennies. 1 penny. Look exactly where it is. Oh, it's like the same spot. Okay. Write that down. Same spot. 2 pennies. But I would actually recommend doing a larger than 2 pennies. If you want to make your life really easy, you could do, say, 10 or 20 pennies at a time. You need at least 5 different independent variable values. So I could go 5, 10, 20, and so on. That would give you a lot. That would give you 20 values. That's like a lot of data. Don't do that much work. I could go by 10 pennies. That would be pretty easy to do. And then I would get 10 values, and that's a good, like pretty large, but good number of independent values, independent variable numbers. And so you can kind of decide that yourself. I'm going to start off by 5. I'm going to add 10 pennies into my cup. Okay, so I have added 10 pennies into my cup. And again, this is really important. You want to make sure you're looking in the exact same way you were looking before. And now I'm going to notice how far the bottom of my rubber binder has moved. So mine was at 3 centimeters, and now it is at 3.2 centimeters. That is this much movement. You are going to be dealing with pretty small measurements in this lab. So if you're getting small numbers, that is what you want. You want to be measuring in centimeters. And so I've got just 3.2 centimeters. What is the stretch then of my rubber binder? Totally. So our stretch is going to be what we are at now minus, minus is hard to spell, our starting point. So we always are going to have the same starting length, because the starting length of the spring is it's not a spring, it's a rubber binder. The starting length of the rubber binder is always the same. So then I'm going to conduct my next value for the independent variable. I'm going to add 10 more pennies from my penny bag. So here I have 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so here are 10 more pennies. I add them into my cup. Great. And now I'm going to do that same thing where I'm going to say, okay, where am I now? Right now, the bottom is at 3.6 centimeters. So now, I'm not at 3.2 anymore. I'm at 3.6 centimeters. What would my new stretch be then? So our new stretch is 0.6 centimeters, or 6/10 of a centimeter. I'm always going back to the same starting point, and I'm subtracting that. So this is what I would write down in my data table. Then I would go ahead and add my next 10 pennies. I'd add my next 10 pennies. I'd get to 50 pennies, and I'd go, Ms. Ginnitz, now I'm stuck. Well, you're not stuck. You can pour out your pennies, put them into your penny bag, or maybe you have a little bowl you're using or something to corral your pennies. And oh, look, 50 pennies. 50 pennies. Now I can add 10 pennies to get to 60, 70, 80, so on. As you're doing this, be careful not to like spill your pennies everywhere. I found it a little bit challenging. I lost some pennies. Don't lose pennies because you are going to want those as masses. Okay, so if you are struggling at all, please ask me. Email me, come to my office hours, whatever. Maybe text me, give me a phone call, whatever. Because I want to help you make sure that you're doing this lab. In a couple of weeks, when we start our second unit, you are going to be conducting another lab that you're actually going to be writing like kind of a lab report for. It's a sample IA. And that's going to be a summative score where you're going to show me that you understand this idea of measurement uncertainty, how to apply it to a lab you conduct in real life, that you understand the idea of repeated trials, statistical uncertainty, error bars, using Desmos, which we'll learn next. You don't know how to do it yet, that's fine. That's what we're learning now. And that you understand how to analyze the results of a lab that you do to really say, what is the mathematical relationship here? And can I predict what will happen when I take it to the extreme, when I hang 200 pennies in my cup? How far will it stretch? You don't have 200 pennies. You don't need to find 200 pennies. I want you to be able to predict mathematically how far will it stretch. Good luck and do your very best.